Hello class, let's look at section 8.2, line, slope, and average rate of change. So, we are going to determine ordered pairs and graph a linear equation in two variables. Find the x and y intercepts of the graph of a linear equation. Find the slope of a non-vertical line given 2 points on a line. Graph a line given its slope and a point on the line. And determine whether two lines are either parallel or perpendicular to each other by comparing their slopes, as well as interpret slope as an average rate of change. Let's look at the linear equation in two variables. An equation that can be written in the form ax plus by equals c, where a and b are not both 0, is a linear equation in two variables. This form is called the standard form. A linear equation in two variables will have solutions written as ordered pairs. In general, these equations will have an infinite number of solutions. All first-degree equations with two variables have straight line graphs. The x-intercept is the point, if any, where the line crosses the x-axis, and the y-intercept is the point, if any, where the line crosses the y-axis. To find the x-intercept of the graph of a linear equation, we let y equal 0 and solve for x. To find the y-intercept, we let x equal 0 and solve for y. Let's find the x and y intercepts of 4x minus y equals 2 and graph the equation. Alright, so now in order to find the x-intercept, we let the y be 0. Okay, so let's see if I can't find the x-intercept. So here we have 4x minus 0 equals 2. That means that 4x equals 2, which means if I divide by 4, x equals 1/2. That means that 1/2 comma 0 is our x-intercept. Okay, now to find the y-intercept, we need to let the x be 0. So we're looking at 4 times 0 minus y equals 2, which means that minus y equals 2, which means that y equals negative 2. You could divide by negative 1 here on both sides to get that. So that our y-intercept here is 0, comma, negative 2. Okay. Now, all we have to do, I'm going to hit back a little bit, is graph both of these points. So if I go 0, negative 2, that point's about right there. If I go 1/2, 0, that point's about right there. If I plot both those points, then I can draw a line between them with arrows on the end, and I have essentially graphed this equation. Now let's try something else. Let's try to graph y equals 3. Now y equals 3. That means y always equals 3, regardless of what the x is. So that's essentially just a horizontal line through 3 on y. So if I count up to 3, 1, 2, 3, that's just a horizontal line through y equals 3. How about x equals negative 2? Well, let's go to where x is negative 2. X is negative 2 right here. So it would just be a vertical line through that point so that x is always negative 2 regardless of what the y is. Now let's talk slope. Slope is the measure of the steepness of a line. That is called the slope of the line. One way to get a measure of steepness of a line is to compare the vertical change in the line, which is the rise, to the horizontal change, which is the run, while moving from one fixed point to another. If x1 is not equal to x2, the slope of the line through the distinct points x1, y1 and x2, y2 is m equals rise over run, or the change in y over the change in x, or y2 minus y1 over x2 minus x1. This is the slope formula. So let's find the slope of the line that passes through the points 3, 5 and negative 2, 1. Okay, now this will be my x1, this will be my y1, this will be my x2, this will be my y2. So remember, we're trying to do y2 minus y1 over x2 minus x1. Okay, well, y2 is 1, y1 is 5. x2 is negative 2, x1 is 3. Okay, so we've got that figured out. 1 minus 5 here is negative 4. And then negative 2 minus 3 is negative 5. And that simplifies down because the negatives cancel out to just 4/5. That is their slope between those 2 points. A vertical line has an equation of the form x equals a, where a is a real number and its slope will be undefined. Why is that the case? Because that gives you a vertical line. And the slope of a vertical line is undefined. A horizontal line has an equation of the form y equals b, where b is a real number and its slope is 0. Remember, you see 0, it's going to reiterate here that that's a horizontal line. Okay. Horizontal lines have slope 0, vertical lines have slope undefined. Why? Because we're looking at rise over run. Okay. Now, if I have a vertical line, it's constantly rising, but it's never running. Okay, so it's going to rise. If you rose 2 points on a vertical line, you would run 0 points. And remember, we cannot divide by 0. That's why it's called undefined. Whereas on the horizontal line, the rise over run, okay, we're not rising anything on a horizontal line, we're staying flat. But we could be running 5, 10, 15, 20, 116, whatever. Now 0 divided by anything is 0, so regardless of what this bottom number is, it's going to still turn out to be 0. So that's why a horizontal line has a slope of 0 and a vertical line has a slope that is undefined. Now let's graph a line that has the slope 2, 3, 2 over 3, and passes through negative 1, 1. Okay, so let's look at this. Let's start with the point, negative 1, 1. Okay, it's right there. Okay, now it has a slope of 2/3, which means we're going to rise 2 and we're going to run 3. So we're going to rise 1, 2, so 1, 2, and we're going to run 3, 1, 2, 3. Okay, and then we are going to connect those 2 dots with a line. We have graphed the line that goes through negative 1, 1 and has a slope of 2/3. All right, now let's look at the difference between positive and negative slopes. A line with a positive slope rises from left to right, whereas a line with a negative slope falls from left to right. Okay, and obviously if we have a horizontal line, it has a 0 slope, and a vertical line has an undefined slope. So we're pretty much able to define positive, negative, 0, and undefined at this point as far as slopes go. Let's look at parallel and perpendicular lines. 2 non-vertical lines with the same slope are parallel. 2 non-vertical parallel lines have the same slope. Furthermore, 2 vertical lines are also parallel. If neither is vertical, 2 perpendicular lines have slopes that are negative reciprocals. That is, their product is negative 1. 2 lines with slopes that are negative reciprocals are perpendicular. Every vertical line is perpendicular to every horizontal line. Okay. Given lines L1 with slopes 2/3, L2 with slope 2/3, and L3 with slope negative 2/3, we have the following. Lines L1 and L2 are parallel, so L1 and L2 are parallel because they have the same slope. L3, though, is perpendicular to both L1 and L2 because its slope is the negative reciprocal of L1 and L2. So negative reciprocal. Reciprocal means you flip it. And negative obviously means that you add the negative to it. Okay? Negative reciprocal. The slope of a line is the ratio of change in y, which is your vertical change, to the change in x, the horizontal change. The idea can be extended to real-life situations as follows. The slope gives an average rate of change y per unit change in x, where the value of y is dependent upon the value of x. Okay, so let's look at this example. It says if a computer was worth $2,000 in the year 2004 and only $800 in 2007, find the average rate of change in the value of the computer over the 3 years. Okay, well, in 2004 it was $2,000, so that would be our initial point. That's our x1, y1. And our new point here would be 2007, which is x2, y2. Okay, then we can use the slope formula. So we can do y2, which is, let's see, they chose a different x1, y1, but it's okay. It works either way. If we do it this way, it's going to be 2007. Did they? No, they didn't. No, we're good. So it's going to, no, they did. They did it a little backwards. It's okay. It works out either way. So I'll erase this real quick. Still works. I'll show you it works both ways. It's a good example of showing that it works both ways. So if I said the y2 was 800 and the y1 was 2000, that means the x2 was 2007 and the x1 is 2004. That's still going to render a 3 on the bottom, and it's going to render, what is that? Negative 1,200 on top, which does simplify to negative 400. So it just goes to show you, as long as you stay consistent with your x1, y1, your x2, y2, it doesn't really matter the order you do them. It works itself out because they chose, for the simplification part here, they actually did it a different way. They said that this was x2, y2, and this is x1, y1. It works out as long as you keep it consistent and don't mix them up. Okay, so either way works. You still get the same answer, negative 400. Value dropped about $400 per year. That concludes this particular chapter. If you have any questions, don't hesitate to email me. Otherwise, I will see you next lecture.